This presentation will discuss the relationship between ethanol and resveratrol on the respiratory and locomotor health of Drosophila melanogaster, otherwise known as fruit flies. Alcohol consumption is a major public health issue today, sadly claiming the lives of approximately 178,000 Americans each year, according to CDC. In 2024, over 61.4 million people in ages 12 and up reported binge drinking in the past month alone. In 2023, 16.4 million people reported heavy alcohol use in the past month. Alcohol use can be defined by two types of exposures: acute or binge drinking, which involves consuming a large amount of alcohol in a short period, and repeated or long-term drinking, which occurs at typically lower doses over a lengthier period of time. Intermediates formed during the metabolism of alcohol processes can produce reactive oxygen species, which can cause oxidative stress and damage cells and tissues. Over time, this can lead to serious health concerns like liver disease, cardiovascular problems, and neurological disorders. Antioxidants are molecules that can mitigate oxidative stress and prevent further cellular damage, and can be found naturally in a variety of foods. Resveratrol is an accessible yet underexplored antioxidant found in grapes and has shown a strong potential to counteract alcohol-induced alterations in the liver specifically, leading to significant improvements in liver function markers. However, previous research has shown conflicting results on resveratrol's ability to mitigate the effects of ethanol. Furthermore, little research focuses on resveratrol's specific effects on ethanol-induced respiratory and locomotor processes. As a result of these research gaps, the purpose of my study was twofold. First, to evaluate the respiratory and locomotive functions, specifically of both acute and repeated ethanol exposure on Drosophila melanogaster, a model organism already established by research as appropriate to use in alcohol-based studies. Second, I looked to determine the potential mitigating effects of resveratrol on ethanol. To test these research objectives, this study conducted entirely at home separated wild Drosophila into control and experimental groups, with each group separated by gender. Negative and positive control groups received no alcohol. However, the positive control received resveratrol, respectively. Experimental groups were divided into two groups, acute and repeated alcohol exposure. Half of the acute groups received resveratrol throughout their diet for 3 days prior to testing. On the third day, all acute groups were exposed to 1 milliliter of 95% ethanol for 16 minutes to mimic acute exposure. Repeated exposure groups received half a milliliter of 30% for 10 minutes daily over 4 days, with half of the group simultaneously receiving resveratrol daily throughout their diet throughout their testing time. In order to determine the effects of alcohol exposure and resveratrol treatment on the respiration of Drosophila, homemade respirometers were created as seen below, and a respiration assay was conducted. An ANOVA analysis showed that both the females and male groups that received acute exposure to alcohol showed a significantly reduced carbon dioxide productions by 33% in females, 38% in males respectively, compared to the initial control value of 1.9 microliters per hour per fly. Remarkably, the addition of resveratrol to these exposed groups significantly improved production by 38% in females and 42% in males, restoring them to a level that was no longer statistically significantly different than controls. Therefore, this research was able to show for the first time that resveratrol can potentially mitigate some of the respiratory effects of acute alcohol intake through simple dietary adjustments. As we can see here, similar trends emerged with the repeated exposure. Across the 4 days, we see rates did seem to stabilize by the end of testing period, likely due to tolerance developed by Drosophila, which has been shown to happen in previous research within a few days. I compared the first and last day results individually as opposed to results over 4 days. During day 1, respiration rates reduced significantly by 29% from the initial control value 1.5 microliters per hour per fly. The slight difference in control values can be attributed to the change in temperature from acute exposure when the experiment was conducted. The addition of resveratrol improved production significantly, generally boosting the carbon dioxide production by 20%. Because I did not want to confine my research to respiration alone, I also conducted a negative geotaxis assay to assess motor coordination, as can be seen above. The number of flies that successfully moved to the 8 centimeter mark within 10 seconds when tapped were recorded as having a positive test. A chi-score analysis showed that with acute ethanol exposure, locomotor abilities were reduced by 37% overall, and resveratrol improved these abilities by significantly by 34% for females. Males showed similar reduction in locomotor processes at 23%. However, resveratrol improved these abilities by 28%, thereby almost returning locomotor rates to baseline levels established by the control groups. Notably, males showed a greater resistance to acute ethanol exposure, as seen by the differences in significance between ethanol and control groups. This aligns with previous research indicating that males generally exhibit a higher tolerance than females. Next, I looked at individual days of repeated exposure. On day 2, we see a reduction on locomotor abilities by 23%, and resveratrol improving these abilities by 17%. On day 4, rates were reduced by 11%, and resveratrol improved these abilities significantly by 14%. We see a gradual decline in ethanol-induced damage, as like in humans, Drosophila were able to build up a tolerance to alcohol when repeatedly exposed. Yet resveratrol consistently improved metabolic rates overall, and in this case to baseline levels. In acute exposure, those who received resveratrol took a longer time to become sedated. A healthy antioxidant-rich diet supports overall health by reducing oxidative stress. Antioxidants like resveratrol neutralize free radicals, preventing cellular damage and reducing the risks of diseases such as cancer. The study highlights the resveratrol's novel ability to mitigate the effects of alcohol consumption, confirming its role in reducing oxidative stress and improving respiratory and locomotor health. These findings expand knowledge on resveratrol's potential as a cost-effective treatment for alcohol-related harm, alongside rehabilitation and therapy. However, limitations include the need for confirmation in mammalian models due to differences from Drosophila. Future research with large samples would explore assays like ATP production and food seeking to further understand resveratrol's impact.